All right, so really in 5.2 and 5.3, there's four things to learn, right? Because your data can either be dependent or independent, so you have these two different cases. And in each of the cases, you want to be able to do hypothesis testing or confidence intervals. So we saw in 5.2 with dependent data, you can do hypothesis testing with a t-test on the differences, or you can make a confidence interval with a t-interval on the differences. And then we moved into 5.3 where we dealt with independent data, and we learned how you can do hypothesis testing on the data using a two-sample t-test. So not on the differences, but instead on the two samples themselves. Well, it turns out you can make a confidence interval as well. So not only can we do a hypothesis testing, I'll show you in this example how we can make a confidence interval. And it probably won't surprise you to hear that just like there's a special calculator function here, namely two-sample t-test, there's going to be a special function down here called two-sample t-interval. Boom, there's a problem through the magic of pause. Same question that I asked over here. We're creating a 99% confidence interval for how many more books males read than females. Like, you already asked that question. Why are you doing it again? Well, because now we're working under the assumption that these are 10 randomly selected males and these are 10 randomly selected females, and there's no connection between the two. In other words, the data is independent. These aren't like married couples or something like it was before. So I'm just randomly selecting these 20 people, 10 male, 10 female, and then I want to create this confidence interval. So, well, confidence intervals used to be 3 steps. First step was to state and justify the shape and talk about the center and the spread. But like we've been talking about in chapter 5, I'm not going to ask you to do that stuff. The formulas get kind of ugly, and you proved to me that you could do it in chapter 4, so don't worry about all that. So we can jump straight to our picture, just like we did over here. When you draw your picture, you're going to draw something that's approximately normal, just like you've been doing the whole class. Well, that's a nice one. And then I'm going to look for 3 things. The level of confidence, 99% in this case. So I want to shade in the middle 99%. And then the point estimate, point in the middle here, and the bounds of your interval. First, you want to put your data into a list. Fortunately, I did that a few videos ago, so I don't have to do that. You just hit the stat key, type your data into some lists. I have males in L1 and females in L2. By the way, the differences are in L3, but I'm not using the differences anymore because, again, I'm dealing with independent data now because I'm working under this assumption and not under this assumption. So it's L1 and L2 where I have males and females respectively. And then what I want to do is hit the stat key, go over to tests, and find something very similar to two-sample t-test, except not for test, but instead for intervals. Well, it's called the exact same thing, two-sample t, and then interval at the end. That 10th thing listed here. If you select two-sample t intervals, say, just like with the others, you can do it with data or statistics. So in theory, I could give you statistics. I think in the homework, maybe you got a few with statistics, but I can just tell you on the quiz this week, on the written problem, on all those, I gave you the data because that's what I depicted more with these examples. So you got the data, huh? All right. Where is what you're going to call list 1? Well, we'll call the males list 1, and that was in L1. And then we'll call the females list 2, and that was in L2. And the reason I want to put them in that order is because the question asks me how many more books males read than females. So they're kind of referencing males in relation to females. So it'll make things work out nicely if I put in males in what they call this list 1 and females in list 2. So since L1 was males, I want L1 to correspond with list 1. Anyways, you tell it your confidence level, which is 99%. You can always tell it you don't want to pool the data because we don't have reason to believe that the standard deviations are the same for males and females. It didn't explicitly tell us that. And by the way, it never will, at least not in our class. So you're always going to say no for pooled. Then you can go down to calculate. And it'll spit out a bunch of information. But the most relevant things are these two values, the bounds on your interval. So I got negative 7.968. And then 11.768. So these are the bounds of my interval. It doesn't explicitly tell me what my point estimate is. And that's kind of unfortunate. Over here, it gave me my point estimate, the 1.9. It doesn't tell me it here. You can figure it out a few ways. One way to figure it out is the point estimate is always halfway in between the two of these. So to find the number halfway in between the two of them, add them up, divide by 2. There's another way, though. What the point estimate is the difference in your sample averages. So it's telling me that the sample average for males was 13.3 and the sample average for females was 11.4. So I can get my point estimate from that by taking this number and subtracting this number. 13.3 minus 11.4 gives me 1.9 as my point estimate. You'll note, since it's the same data that I use to create these differences, the point estimate here will be the same as it was over here. But over here, it gave it to me explicitly. This time it doesn't. So this is the entire picture that you want. And then I'll ask you, explain what that means. And it'll be essentially this with different numbers. You'll say, I am 99% sure that the average number of books read by all males is between, and then I'll quote these two numbers, 7.968 less and 11.768 more than the average number of books read by all females. And that's it. There's nothing more that I have to add to this. Same things to be careful of over here as being careful of over here. Make sure you understand what negative numbers mean. And then be careful on what you choose for your first list and your second list. These answers always tell you how much more what you call list 1 is than what you call list 2. So I'm going to try to ask these in the most logical way possible. I'll give you the data, and the data that I give you first will be the one that'll make the most sense to put in for list 1. But in a less contrived situation, maybe if it wasn't an intro to statistics class, it'd be good if you understood that. So again, quick recap of this entire section. If you can, get a problem, like what it says in red here and what it says in red here, and immediately tell whether it's dependent or independent data. And then have solid in your head that if it's dependent data, then it makes sense to take the differences. And if you're taking the differences, you only have one column of data, so you can just do stuff that you did in 5.1. Just do t-test and t-interval. But if you have independent data like you do down here, well, it makes no sense to take the differences because they're not connected. Why would you subtract them? But that's a problem. Then I have 2 sets of data. I've never dealt with 2 sets of data. Don't worry, there's 2 new calculator functions, 2 sample t-test and 2 sample t-interval, and those are built just to answer these questions. If you draw the pictures, make the conclusions, and state the null and alternative hypotheses, you know everything that I could ever imagine asking you from 5.2 and 5.3.